Hello, math students. This is Mrs. Smith, and we're going to be going over your Chapter 10 test review for math, volume, and surface area. Okay, let's get started. Olivia is placing a gift inside a box that measures 15 centimeters by 8 centimeters by 3 centimeters. What is the surface area of the box? All right, when we're solving this problem, we need to remember that area equals base times height. And in the end, whatever units we have, it will be squared. When we take a look at our rectangular prism, we see that it has 6 faces. And they are, we have the front, right here, and then the back, and they are congruent. That means that they are the same size and the same shape. Then we have a left side and a right side. And they are congruent. And then we have a top, and we have a bottom, and they are congruent. So when we find area for one, we can use that for the other one. We don't have to compute it. We can just write it twice. I'm going to autofocus this for a sec. All right. Now, when I look at the front, I see that it is 3 centimeters, and then I have this long side here. And that's the front. Well, this long side is 15 centimeters. So I will have 3 centimeters times 15 centimeters, which equals 45 centimeters squared. The back is congruent, so that will also be 45 centimeters squared. When I look at the left and right sides, I see that I have an 8 by 15 rectangle. So the width is 8 centimeters times 15 centimeters, and that equals 120 centimeters squared for the left side and 120 centimeters squared for the right side. The top and bottom are 3 centimeters by 8 centimeters. We're multiplying again. So we have 3 centimeters times 8 centimeters, and that equals 24 centimeters for each face, the top and the bottom. Now I need to add all of these up. To save a little bit of time, I'm going to make this 90. Add these two up. This is 90 centimeters. This is 240 centimeters squared, and this is 48 centimeters squared. And when I add these values together, I get 378 centimeters squared. And that would be answer choice A. All right, question number 2. Sandy drinks the same amount of water every week as shown in the table. All right, when we look at this table, we can look at this many different ways. We can look at it horizontally on the bottom row, horizontally on the top row, and up and down. So horizontally on the bottom row, I'm adding 1 for each column. Each column move is an addition of 1. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. When I go horizontally on the top, if you use your calculator, you would do 17 take away 85 or 8.5, and you'd get 8.5. So we're going to add 8.5 plus 8.5 plus 8.5. Now, if you didn't know that, you need to go and do that with a calculator now. Just don't trust me. Make sure that you know what I'm saying and prove it to yourself. So horizontal moves can be addition and subtraction. Vertical moves have to be have to be multiplying or dividing. To get from 1 to 8.5, I multiply times 8.5. 2 times 8.5, I'm going to do it right here. 8.5 times 2 is 17. Oops, and that's 17. So movement from the bottom to the top is multiplying by 8.5. So I'm going to multiply 5 times 8.5. 8.5 times 5. 1 decimal point. That's 42.5, which is H. Okay, question number 3. Rigo is buying a subscription to a sports magazine that costs $2.19 per issue. Which of the following is a good estimate for the cost of 12 issues? Note here that they want us to estimate. Let me move this up a little bit. All right, so we know that one issue is $2.19 per issue. And he wants to purchase 12 issues. 12 issues. I'm going to round $2.19 to $2. I'm going to keep 12 because 2 is an easy number to multiply by, and that will give me $24 approximately, which is answer choice C. Question number 4. Nail Magic sells 2 different rectangular mailing boxes with the dimensions shown in the table. What is the volume of box B in cubic inches? Now remember, area are units squared because we only have 2 units, base times height, length times width. Volume are units cubed because we have 3 dimensions, length, width, and height. And perimeter is just units because the only dimension we're using there is length. All right? So these little numbers are kind of important. Now you're not going to see a 1 here because the 1 is assumed. Okay. So she wants to find the volume of box B in cubic inches. Well, box B is here, and volume equals length times width times height. I do use a cursive L because I don't want it to look like the number 1. So volume is going to equal length, 10 inches, times width, 8 inches, times height, 8 inches. 10 inches times 8 inches is 80 inches squared. 80 inches squared times 8 inches would be 640 inches cubed. Remember, when you multiply, that changes the number, the little superscript number. All right, so we have, this is an answer that we just write, 640 inches cubed. Question number 5. What is the area of the triangle? Area equals 1/2 times the base times the height. You want to rotate your triangle until you identify a bottom, which will be your base. In this case, our base is 14. So we have 1/2 times 14. the height is the distance from the base to the apex of your triangle, which is the tippy top. That line must be perpendicular. In this particular square, the sides are not the height. It's indicated by this dashed line, and it is 8 centimeters. So area equals half of 14, which is 7 centimeters, times 8 centimeters. Area equals 56 centimeters squared. And that is answer choice H. Next, we have a parallelogram. What is the area of the parallelogram shown below? Area for parallelograms is area equals base times height, 2 dimensions. The base is 10.5 centimeters times the height. The height is the distance from the bottom base all the way to the top. In this case, it is not the side lengths because they are not perpendicular. Again, height is a perpendicular measurement. So it is 12.4 centimeters. If you multiply them together, and you can use a calculator if you wish, you get 130.2 centimeters squared. And that also is an answer that you have to write down, not multiple choice. Which function rule describes the relationship between x, time traveled, and y, distance from home? Take a moment to look at this graph if you haven't, and I hope you have, because I need you to make sure that you're doing these problems. It's not okay to have me do them and then just copy it, because you want to make sure you know how to do the problems. All right. So we have, what I do here is convert this to an in and out table. If you remember those from elementary school and then earlier this year. In and out tables are what we do in elementary school. When you're in 7th grade, they become X, Y tables. And in this case, X is time and Y is distance. Notice they do include the unit. In this case, it's hours and miles. So it makes sense that at no time, so at the beginning, 0 is your time, and your distance from home is 0 because you're at home. An hour later, you are 65 miles from home. To think critically about this problem, ask yourself, am I walking, running, riding a bike, driving a car, or flying from an airplane? What do you think you're doing if you can get away from your house in 1 hour and go 65 miles away? Well, chances are you're probably driving a car. All right, so we have, all right. So if the time is 0, the distance you traveled is 0. If the time is 1, the distance you traveled is 65. If the time is 2 hours, it's 130. And if it's 3 hours, the time is 195. So you have to ask yourself, how do I get from X to Y? Because X always comes first and then Y. Well, the easiest one is here. You can see number 1. Hour 1. 1 times 65 equals 65. Well, with a calculator, do 2 times 65. Does that give you 130? It does. Does 3 times 65 give you 195? Yep, it does. And does 0 times 65 equal 0? Yes. All right, so we know we're multiplying by 65. We're actually multiplying x times 65. So whatever is here, we're going to multiply by 65. All right, so I have x times 65 equals y. Well, when I look down here, I don't see anything that looks like this, like what I wrote. Well, I remember that I can actually write this multiplication problem as 65x equals y. Okay. Now this one has y equals x, so that can't be right. And this has got division in it, which I'm not seeing that working out. And this one has addition, and that's not working out. Now this one looks similar because I see 65x and I see y. Yes, it's okay to write y equals 65x. You haven't changed anything. I just told you the answer before the problem. Personally, I like to give you the problem and then the answer, but sometimes you got to do it the other way around. All right? So, answer D. There you go. All righty. Moving on to question number 8. What is the area of a trapezoid, shown below in square feet? The formula for area of a trapezoid equals area equals 1/2 times base 1 plus base 2 times the height. Now, I have seen instances where and maybe even in your textbook, it's area equals base 1 plus base 2 times the height divided by 2. That is totally okay. Okay. Multiplying by 1/2 and dividing by 2 is the same thing. All right? So we are going to use this formula. And let's identify the two bases. So the bases have to be parallel in a trapezoid, and there's only one pair of parallel lines. So it's the top base and the bottom base. So area is going to equal 1/2 times 5 feet plus 9 feet times the height, which is indicated by this dashed line perpendicular to the base, and that is 7 feet. So area equals 1/2. Now I'm adding here, so this will be 14 feet, not feet squared, because I'm adding. If I were multiplying, it would be feet squared, but we're adding. Times 7 feet. Area equals 1/2 of 14 feet is 7 feet times 7 feet. Area equals 49 feet squared, again, because I am multiplying, and area is a two-dimensional measurement. You have to have 2 dimensions to figure out the area. So we have 49 feet squared. Question number 9. Super Toys makes two sizes of cube-shaped building blocks. The larger block has side lengths 4 times the side lengths of the smaller block. What is the ratio of the surface area of the small block to the surface area of the large block? All right, so let's draw 2 boxes or 2 cubes. Now, the one good thing about cubes is that all the side lengths of the cube are the same length. And it says here that the side lengths, the ratio is that this one is 4 times bigger. All right, 4 times larger. So if this were 1 centimeter, I'm going to multiply by 4, and this will be 4 centimeters. This is a cube, so the other sides are also going to be the same lengths. So 1, and this is going to be 4 centimeters. So the surface area of just one side of this small cube would be 1 centimeter times 1 centimeter, which will give us 1 centimeter squared. And that's for one face. This is a cube. There are 6 faces. So I'm going to multiply 1 centimeter. Oh, I apologize if I said cubed. I meant squared. I wrote squared. Squared times 6 faces. And that will be 6 centimeters squared. That's the area. Now the area for the larger cube would be 4 centimeters times 4 centimeters. So the area will equal 16 centimeters squared. So that's for the front side, or the front face. There are 6 faces, so we're going to do 16 centimeters squared times 6 faces. And you get 96, wait, is that right? No, 6, yes, yeah, 96 centimeters, squared. All right, so what do I have to multiply to go from 6 centimeters to 96 centimeters? Well, let's divide. 96 divided by 6 is times 16. This makes sense. Centimeters from here to here and multiply by 4. This is a 1-to-1 relationship. But notice here, this is a squared, area is squared. So I actually have to multiply by 4 squared. And 4 squared equals 16. So to get from the length sides, or the perimeter, you just multiply. But for area, since it's a square measurement, you have to do whatever the enlargement was squared. And that will tell you how much the area increases during the enlargement. All right, and that was, so it would be 1 to 16. For every, the area is for every square centimeter, for every square centimeter, you're going to get 16 centimeters squared. You see that right here? All right, moving on. We have another trapezoid question to find the area, and area equals 1/2 base 1 plus base 2 times the height. The bases are parallel to one another, so we have 3 and we have 11. So it's 1/2 times 3 inches plus 11 inches times 5 inches. So area equals 1/2 times 14 inches, remember adding, times 5 inches. Area equals 7 inches times 5 inches. Area equals 35 inches squared. Okay. question number 11. Hold on a sec. Question number 11. All right. I need 2 index cards for this one. It's a little bit longer. Okay. A rectangular prism has a surface area of 254 square meters, a height of 9 meters, and a length of 7 meters. What is the measure of the width of the prism? Okay, so let's draw this out. So we have a prism here. I know that it's 9 meters, so that means every single one of these is 9 meters. And then this part right here is 7 meters, and I don't know what the width is. I know that the area equals, the total surface area equals 254 meters squared. All right, and hold on one sec. I'm going to see if I can change my pencil. Okay. Let's identify the faces. Again, we have a front and a back, a left side and a right side, and then we have a top and a bottom. Okay, this is involved, all right? But what I want you to know is that you have to write down what you know, because believe it or not, if you take the time to write down what you know, a lot of the times the solution comes to you. All right, so let's take a look at the front here. That's right here. What are the dimensions of the front? Because I want to find area. Area equals the base times the height. Well, I can see that it's 7 times 9. So I'm going to do 7 meters times 9 meters. And that gives me 63 meters squared. And the back is going to be the same thing, 63 meters squared. Okay, let's look at the left and the right sides. Well, I see here W and 9. I don't know what the width is, so I'm just going to write 9 meters times W equals. And the top I see here is 7, and this is W. So I'm going to write 7 meters times W. Okay. I know that the total surface area is 254 meters squared. Right now, I have accounted for 26 meters squared of that volume. So I'm going to subtract, and I get 128 meters squared left over. I have to divide that up between all of these sides. Or faces. There are 4 faces left. So approximately, what would the area have to be of each side? Let's say that they were all the same. We would do 128 divided by 4, which is 32. So approximately, this should be about 32, about 32, about 32, and about 32. So in my mind, I'm going to be thinking, what times 9 will give me an answer around 32? It could be a little more, it could be a little less. For 7, it could be a little more, it could be a little less. Okay, so I'm thinking here, 9 times 3 is 27. 9 times 4 is 36. Okay. Here I'm thinking 7 times 4 is 28. 7 times 5 is 35. Okay, so these are probably the numbers that I'm going to be using. And look, this one has a 4 and this one has a 4. So wouldn't that make sense that, because it has to be the same number because it's W. All right, so let's make W a 4. Hold on 1 sec. Okay, so I'm going to make W worth 4. I'm just going to put a 4 here. 9 times 4 is 36 meters squared. 9 times 4 is 36 meters squared. 4 times 7 is 28 meters squared. 28 meters squared. All right, so when I add all of these up, hopefully I will get 254. Well, I told you already this adds up to 126. This adds up to 72. And this adds up to 56. 6, 7, 8, 12, 13, 14, 14, carry the 1. 12, 13, 14, 15, carry the 1. 2. Yay! We got the right answer. That is problem solving. Notice how you have to make things line up with a plan, but you can do it. Alrighty, so that was A, 4 meters equals the width. All right, next. A rectangular prism has a volume of 60 cubic feet, a width of 2 feet, and a height of 3 feet. What is the measurement of the length of the prism? Now this one is going to be a little easier. This is the formula, volume equals length times width times height, okay? And we are told that the volume is 60 feet cubed. The width is 2 feet, so I'm going to put 2 feet. The height is 3 feet. And we do not know the length. So I have 60 feet cubed equals the length times 6 feet squared. Now I'm going to divide by 6 feet squared. Divide by 6 feet squared. That cancels it out, and L equals 60 divided by 6 is 10. Now I want to focus on this part. This is actually feet times feet times feet. Oops, sorry. Feet times feet times feet over feet. Good afternoon. Times feet. So feet over feet cancels each other out, and feet over feet cancel each other out. So this just leaves feet. So you have 10 feet equals the length, which makes sense because that's only one dimension. How long something is just one dimension. So the answer is 10 feet. Answer I. All right, question number 13. The table shows the cost of renting a booth at a fall festival. There's an initial charge for reserving a booth and a fee per day. So there's an initial charge and a fee per day. So there's 2 charges. What is the cost in dollars of renting a booth for all 7 days of the festival? Okay, so here we go. So day 0 is $50. Now, that's important because you haven't rented it for the day. It just costs $0 to do what? To rent it. That is our initial charge. Okay? So now 1 day is a total of 90. 2 days is 130. 3 days is 170. So we have, I'm going to make this dark here. So we have our initial charge and then the daily rate, basically, the day, the rental cost by day. All right? So it's 0 because we haven't gotten it for any amount of time, plus $50. All right, so if the charge is always going to be $50, we can fill that out here. So that means the rental was $40 the rental was 130, take away 50 is 80, and then this would be 120. Okay? So this would be 50, 50, 50, and 50. So basically it's $40 per day plus $50. It's $40 per day plus $50. So for 7 days, you would do 40 times 7 plus 50. 40 times 7 plus 50. So that would equal 280 plus 50, which is 330 total. And that is answer choice B. Question 14, a rectangle has an area of 318 square centimeters and a width of 12 centimeters. What is the length of the rectangle in centimeters? So we have the area is 318 centimeters squared, and they're saying the width and length. Just so you know, you can write area equals length times width. So they have 318 centimeters squared equals, let's see here, 12, and we don't know. We don't know the length, but we know that this is 12 centimeters squared. Okay, so now what we're going to do is divide by 12 to get our answer. 12 centimeters squared. Oh no, just 12 centimeters, sorry. 12 centimeters. I'm trying to rush, I apologize. Centimeters. So that's so we have L equals, and then we have to figure out 318 divided by 12. And 318 divided by 12 is 26.5 centimeters. And again, right here, you have centimeters squared over centimeters, which is centimeters times centimeters over centimeters. They cancel each other out. So that's why I only have 1 centimeter left. So it's 26.5 centimeters is the length. Okay. Question number 5, we have a gift. Laura is gift wrapping the box shown. Part A, find the volume of the box. Okay, so we have, let's go ahead and do this here. All right, so we have volume is going to equal length times width times height. So the volume is going to equal 15 inches times 9 inches times 3 inches. So the volume is going to equal 15 times 9, 45, 9, 10, 11, 12, 13, 135 inches squared times 3 inches, which equals 4.
The 3:40 bell did not ring, so the students are dismissed now for the 3:40 bell.
Okay, so to find the volume is going to be 405 inches cubed. Okay, now if each dimension is doubled, explain what happens. The second part to our question, part B, asks if each dimension is doubled, explain what happens to the volume. Now for this, I actually want to draw out our rectangular prisms. So let me go. All right, so we have 15 by 9 by 3. And then we're going to make it bigger. We're going to double it, so that's 30 by 18 inches by 6 inches, doubling, times 2, right? This is times 2. All right. So, here we go. We've already established that the volume of the smaller rectangular prism was 405 inches cubed. So volume equals 405 inches cubed. So we're going to figure out this one. This one's going to be volume equals 30 inches times 18 inches times 6 inches. So the volume here is going to be 540 inches squared times 6 inches. So the volume is going to equal 3,240 inches cubed. So what happens to the volume when each dimension is doubled? So we doubled the volume here. We multiplied all of these measurements by 2. So what is that going to do here? Well, obviously it increased it. And here's the thing. Remember I told you a few problems back that if it was area, since area was a squared measurement, inches squared, that means that we'd have to do 2 squared and multiply by that. Well, this is inches cubed. So what do you think we're going to have to measure by or multiply by? 2 to the 3rd power. So we'd have to do times 2 to the 3rd power, which equals 2 times 2 times 2, which is 4 times 2, which equals 8. So let's see. If I multiply by 8, will I get 3,240? Well, 405 times 8, 40, 32. Yes. So when we double each dimension, it actually...
Please make sure you're saying...
So here we had to do it cubed. So it's actually going to be 8 times bigger. All right. So the volume equals 3,240 inches cubed, and that is 8 times greater. Next, they're asking us to just double one of the dimensions, okay? Not all of them. So volume, we had our volume originally be 15 inches times 9 inches times 3 inches equals 405 inches cubed. Now they want us to just double one. So this is length, width, and height. All right, let's make this double. 30 inches times 9 inches times 3 inches. And then this time, let's double the width. So it'll be 15 inches times 18 inches times 3 inches. And the last time, let's do 15 inches times 9 inches times 6 inches. So I doubled this one, I doubled this one, and then I doubled this one, but the others stayed the same. All right, when you multiply this together, you get 810 inches cubed. When you multiply these together, you get 810 inches cubed. And when you multiply this together, it's 810 inches cubed. And when you double just one dimension, it doubles the volume. All right, and there you have it. Now, this was a lot. I'm not going to lie to you. This is a challenging test. Please use a calculator and make sure that when you were going through this with me, you were taking your time and working along with me if you did not get the correct answer the first time. Well, everyone, I hope that you do very well on your math assessment, and I wish you a fantastic day. Bye-bye.